So crypto system, tuples of crypto system are encryption algorithm, decryption algorithm, key, plain text and cipher text. So first we'll see Euclid's algorithm. Euclid's algorithm is used to calculate the GCD of a number. So how can you calculate the GCD? The GCD of a number A and B. There are two numbers A and B. How will you calculate the GCD? The GCD will be B comma A mod B. So for example, there is a number given to me as 21 comma 45. So GCD of 21 comma 45 will be GCD of 21 comma 45 mod 21. So GCD will be 21 comma 45 mod 21 will be 21 2s are 42 and remainder is 3. So 21 comma 3. Then you will write GCD of 21 mod 3 comma 3. GCD of 21 mod 3 is 0 because 3 is completely divisible. 3 7s are 21 is completely divisible. So 3 7s is 21. So 0 comma 3. So final answer is GCD is 3. So whenever we get the remainder as 0, we stop there. Here we got the remainder as 0. So we will stop here. This is the Euclid's algorithm. Next is Euler-Totent's function. Number of positive integers less than n and relatively prime to n. In Euler-Totent function, there are two rules. Rule number 1 says that if the number is prime, then the formula for the function will be simply n minus 1. But if the number is not prime, however, the factors are prime. Then we simply do P1 minus 1 into P2 minus 1. That means if we take this example, here the number is not prime. 6 is not a prime number, but the factors of 6 are 3 into 2. So we do 3 minus 1 into 2 minus 1. That is 2 into 1, which is equal to 2. So your answer for the Euler-Totent's function is 2. So here you got this as 2. So this 7 is what? 7 is prime. So we use this formula of n minus 1. So we do 7 minus 1, that is 6. 11 is also a prime number. So you will do simply 11 minus 1. So answer is 10. Euler's theorem. So what is Euler's theorem? For every a and n which are relatively prime, your formula is a raised to the Euler-Totent's function mod of n equal to 1. So Euler's theorem we have to find for a equal to 3, n equal to 10. So here we will write 3 mod of n, that is psi of n. Psi of n, your Euler-Totent's function where n is 10. If n is 10 but the factors are prime, 5 into 2 is prime. So we simply do 5 minus 1 into 2 minus 1, that is 4 into 1, that is 4. So if you substitute in this formula, you get A is 3 raised to 4 mod 10 equal to 1. Next is Fermat's theorem. If P is prime and A is positive integer not divisible by P, then we have this formula. A raised to P minus 1 mod P equal to 1. So simply A raised to 18 mod 19 is 1. This number and this number. So this number is 1 less than the P, that is P minus 1, then your answer will always be equal to 1. So in this example, A is 3, P is 5. So 3 raised to 4 mod 5 will always be equal to 1 because this is P and this is P minus 1. Similarly, for this, if I have to calculate, I will split this into 3 raised to 10 mod 11, 20 times into 3 raised to 1. Now, we know that 3 raised to 10 mod 11 will always be equal to 1. And 3 raised to 1 is 3. So, 3 into 1, answer is 3. So, these are the various theorems. The first is Euclid's algorithm. We saw Euler-Totent's function. Then we saw Euler's theorem and the Fermat's theorem.